Have you ever wondered what actually is time? Is it a constant, unchanging flow, or a malleable entity that bends to the whim of the universe? These questions have puzzled philosophers and scientists alike for centuries. According to Albert Einstein, a man synonymous with genius and known for his iconic shock of white hair, time is not as straightforward as it may seem. His theory of special relativity, proposed in the early 20th century, fundamentally changed our understanding of the universe and its elusive fourth dimension, time. In a nutshell, Einstein's theory of special relativity suggests that time is not the same for everyone, everywhere. Instead, it is relative and personal to each observer, depending on their speed and gravity. For instance, if you were moving at a high speed or were close to a massive object, time would slow down for you relative to someone who was stationary or far from the massive object. This mind-bending concept, known as time dilation, implies that time travel into the future is theoretically possible. In fact, it has been demonstrated through several experiments. The most famous of these is the case of two synchronized atomic clocks, one sent on a high-speed journey and the other left stationary on Earth. Upon return, the traveling clock was found to have ticked fewer times, effectively traveling into the future. However, Einstein's theory also suggests that traveling back in time to the past is riddled with paradoxes and remains purely theoretical. For instance, what if you traveled back in time and prevented your own birth? This is known as the grandfather paradox, and it highlights the complexities of time travel. Another intriguing concept related to time is entropy, a measure of disorder in the universe. Some physicists suggest that the increasing entropy gives a direction to time, from past to future, from order to disorder. However, whether entropy truly dictates the flow of time remains a topic of heated debate. While most theories treat time as continuous, some propose that there may be a smallest unit of space-time, a concept known as loop quantum gravity. This theory challenges the conventional notion of time, suggesting that it may be quantized or made up of indivisible units, much like a film reel made up of individual frames. In conclusion, time is far more complex and relative than we often consider. Einstein's theory of special relativity showed us that time can stretch and squeeze depending on an observer's speed and gravity. Time travel into the future is possible and has been demonstrated, while traveling to the past is theoretical and fraught with paradoxes. The concept of entropy suggests a direction for time, but its role is still unclear. And finally, time may not be continuous, but made up of smallest units, a theory still under investigation. So the next time you glance at your wristwatch or the clock on the wall, remember that what you're observing is your own personal slice of time, unique to you and your place in the universe. And who knows, maybe one day we'll unravel the full mystery of this enigmatic fourth dimension. Until then, time, it seems, will keep ticking away in its own relative way,